Imagine discovering a celestial object that challenges everything we thought we knew about the universe. The most distant star ever identified, affectionately named Earendel, derived from the Old English term for morning star, might not be a star at all. Recent findings from the James Webb Space Telescope, JWST, suggest that this intriguing object could actually be a cluster of stars, rather than a solitary star, as previously believed. Earendel was first spotted by the Hubble Space Telescope in 2022, and it was initially thought to have formed just 900 million years after the Big Bang, a time when the universe was merely 7% of its current age. However, a new study published on July 31st in the Astrophysical Journal has prompted astronomers to reconsider this classification. They utilized the advanced capabilities of the JWST to re-examine Earendel, leading to the hypothesis that it might be a compact star cluster, a collection of stars that are gravitationally bound and originated from the same gas and dust cloud. The researchers discovered that the spectral characteristics of Earendel align more closely with those of globular clusters, which are a specific type of star cluster found in our local universe. Massimo Pascal, a doctoral student in astronomy at the University of California, Berkeley, and the lead author of the study, expressed optimism about these findings. He stated, "What's reassuring about this work is that if Earendel really is a star cluster, it isn't unexpected. This work finds that Earendel seems fairly consistent with how we expect globular clusters we see in the local universe would have looked in the first billion years of the universe." Located in the Sunrise Arc galaxy, Earendel is an astonishing 12.9 billion light-years away from Earth. Its discovery was made possible through a fascinating phenomenon known as gravitational lensing, which was predicted by Einstein's theory of general relativity. This occurs when massive objects, like a galaxy cluster situated between Earth and Earendel, warp the fabric of space-time, bending and magnifying the light from distant objects. This effect allowed astronomers to observe Earendel's light, which would otherwise be too faint to detect. In fact, studies suggest that due to gravitational lensing, Earendel appears at least 4,000 times larger than it actually is. The magnifying effect of gravitational lensing is particularly strong in certain areas. If a star or galaxy is positioned near one of these regions, its image can be amplified hundreds or even thousands of times brighter than usual. Earendel is fortunate to be located very close to one of these sweet spots, which is why we can see it despite its incredible distance. Such precise alignments are exceedingly rare, prompting astronomers to explore alternative explanations beyond the notion of a single star. After Earendel's initial discovery, researchers utilized data from JWST's near-infrared imager, NIRCam, to analyze the object further. They assessed its brightness and size, concluding that Earendel could be a massive star, potentially more than twice as hot as our sun and about 1 million times more luminous. Additionally, they detected hints of a cooler companion star in the color spectrum of Earendel. Pascal noted, after some recent work showed that indeed Earendel could, but is not necessarily, be much larger than previously thought, I was convinced it was worthwhile to explore the star cluster scenario. Using spectroscopic data from JWST's NIR-SPEC instruments, Pascal and his team examined Earendel's age and metal content. They analyzed the spectroscopic continuum of Earendel, which illustrates how its brightness varies across different wavelengths of light. This pattern was consistent with what one would expect from a star cluster, or at the very least, it resembled the combined light of multiple stars. Brian Welch, a postdoctoral researcher at the University of Maryland and NASA's Goddard Space Flight Center, who led the team that discovered Earendel in 2022 but was not involved in the new study, commented on the findings. He stated, "At the spectral resolution of the NIR SPEC instrument, the spectrum of a lens star and a star cluster can be very similar. It is therefore important to consider all available data when attempting to classify these highly magnified objects." Welch also pointed out that the researchers focus solely on the star cluster hypothesis, which limits the scope of their study. He remarked, "The measurement is robust and well done, but in only considering the star cluster hypothesis, the study is limited in scope." Both Pascal and Welch agree that the key to unraveling the mystery of Earendel lies in monitoring microlensing effects. Microlensing is a specific type of gravitational lensing where a passing object temporarily distorts the image of a distant object when a nearer object aligns in front of it. Changes in brightness due to microlensing are more pronounced when the distant objects are smaller, such as stars or planets, rather than larger star clusters. Pascal expressed excitement about the potential of future JWST programs to shed more light on the nature of Earendel, stating, "It will be exciting to see what future JWST programs could do to further demystify the nature of Earendel." As we continue to explore the cosmos, the question remains, could Earendel truly be a star cluster, or is it something entirely different? What are your thoughts on this intriguing discovery? Join the conversation in the comments below.